everyone, or probably evening at this point. I haven't checked the time. My name is Riris. I'm currently a postdoctoral research associate at University College London. And today I'm going to be presenting my research with Fabio Silva, who just started Marie Curie postdoc in Tarragona, not too far from here, on dates and dispersions and how to model the latter with the former, using a case study of the Guaraní expansion into the La Plata basin using Monte Carlo methods. Fabio unfortunately couldn't be here today because he's surveying a medieval settlement. He gets to fly a drone, I think. He's lucky. So basically just an introduction to our research. Our question is, can the current body of absolute dates for the Guaraní culture adequately explain its pre-contact distribution in terms of an expansion process? I'm going to qualify the various bits and pieces of that research question as time goes on. I'm going to launch into the historical background to the Tupi-Guarani language and culture and the Tupi-Guarani archaeological culture as understood by archaeologists. Look into some of the preceding paradigms and models behind this hypothesized expansion process before moving into describing the available C14, 14C and thermoluminescence data for the La Plata Basin, introduce a method, and then go over some results and discussion and present some preliminary conclusions. We are currently writing this up as we speak, pretty much. So, brief continental overview. Based on glottochronology, ironically it's a hard word to say, linguists have hypothesized an origin for the Proto-Tupi or Old Tupi language somewhere in the headwaters of the Madeira River, the state of what is now Rondônia, sort of northern Bolivia. This is a highly simplified phylogenetic chart of this macro stock of languages. And today, basically, what I'm going to be focusing on is the Guarani subset of the Tupi-Guarani family. So at some point in probably the last 5,000 years or so, Tupi-Guarani split off from the old Tupi stock, one branch going down across the Atlantic coast of modern Brazil, and the other one passing sort of through Bolivia and Paraguay, Mato Grosso do Sul, to arrive at its known pre-contact distribution. This is what is known as the Guarani today. Very briefly, they had a very, relatively homogeneous material culture package defined primarily upon brushed, corrugated, and polychrome pottery, a very repetitive settlement pattern focused mainly on palisaded villages near to major rivers, major river valleys. And yes, they've also been associated with these villages have also been associated with patches of terra preta throughout the area of their dispersal. So the canonical, if you like, model for this dispersal process, or expansion process as it's also called, is in the work of José Brochado, who worked with Donald Lathrop in Illinois in the 1980s. And José basically proposed a initial expansion through what is now Paraguay, before spreading up through the upper Paraná, and another branch going down through the lower Paraná to arrive at the mouth of the Rio de la Plata, so just before the contact period. And then various pulses and phasings in the meantime, especially towards the Atlantic coast of Brazil. Recently, Bonomo et al. And colleagues at the University of Buenos Aires proposed a new model based on the vast amount of new radiocarbon dates that have emerged since the 80s in this area. I think all of Brochado's thesis at the time contained about 29 radiocarbon dates for most of lowland South America, and based on their close reading of the radiocarbon data that they were managed to collect, they present their conclusions in a recent paper in Quaternary International, being slightly more agnostic about the point of origin, sort of this kind of maybe area rather than straight down the Paraguay like Brochado proposed, and their phasings are a little bit different from his, but essentially it's almost the same model. So what we have here is effectively two elaborate hypotheses about the origins of the Guaraní expansion, the directionality, the timing, and furthermore, Bonomo et al. Proposed several hiatuses or two hiatuses rather, in the expansion process, sort of very slow, at least, expansion around 1000 AD before a massive sort of boom afterwards. So, we used in our analysis a total of 247 absolute dates, 144 C14 and AMS dates, and then a bunch more thermoluminescence determinations. The data span across Mato Grosso do Sul, Rio Grande do Sul, Santa Catarina, Paraná, and Sao Paulo, and in Argentina, Misiones, Corrientes, Entre Rios, and Buenos Aires, and bits and pieces of Uruguay. Our oldest site in the sample is the Fazenda Dona Carlota, which is in Paraná. You have the date there, and this represents an accumulation of about 40 years of research 40 years of research that was able to make radiocarbon determinations in the area. Now, of course, we're very, very grateful to Bonomo and colleagues for publishing this data along with the Quaternary International article, thus allowing us to make use of it. So what I'm about to show you is an animation of all of these dates in sequence, in 100-year bins, in century bins, in this study area. So it begins with the Fazenda Dona Carlota site. It's quite a fast animation. But around 1000 AD, the first dates will arrive in the mouth of La Plata. There's this big boom around 1400 before a gradual sort of fall off into the modern period, and then the animation repeats itself. Now, I don't know about you, but I'm having a hard time kind of seeing other than in incredibly gross terms, how this represents an expansion process along specific corridors, other than, again, sort of just the river valleys. So what we did is take this data set, and this is what it looks like instantly calibrated. The x-axis is just its entry number in the database. How have we sorted this? Yeah, so young dates are high, old dates are low, and you can see the spread of the errors. Some of these error bars are quite large, and many of them. Black dots represent the mode, and clear dots represent the median of the calibrated date range. So next up is the dataset sorted by geodesic distance from the Fazenda Dona Carlota site. There's far less structure. I mean, the only structure in this one is the fact that in the database itself, older dates tend to have lower numbers. But when you sort the data from distance, in terms of distance from the Fazenda Dona Carlota site, there is far less structure overall. So these tail end dates here represent sort of Sao Paulo and the area around Buenos Aires. So there's an obvious late bias, first of all, and yeah. So we chose to, as in previous studies, we have chosen to use quantile regression to model the relationship between distance from the origin and between early Guarani dates as the dependent variable and each site's distance from the proposed origin place. So whereas something like ordinary least squares regression approximates to the conditional mean, quantile regression is attractive because it allows you to regress to a chosen percentile of the data set. If you choose a low percentile, that basically can be treated as a proxy for the earliest arrival of a chosen phenomenon, in this case the Guarani expansion, to in a given region. So it's also preferable to something like weighted regression or data filtering because it allows you to use the whole data set. We're not making any choices about the quality of this data. We're taking it kind of at face value, but I'll get into how we treat the data analytically in a second. So what we did is sample this data that's actually inaccurate. We actually did it 100,000 times. We sampled these distributions of each dates 100,000 times and then regressed to the first percentile. And one thing I want to highlight here before I go into the significance testing of these results is the negative and the multiple invisible flat lines here. Now they're only about 4.4% of the total number of regressions we performed, but these basically represent dispersal processes that, in the case of flat, happened instantaneously, or in the case of negative slopes, actually represent a dispersal in the opposite direction. That is, from the mouth of the La Plata towards the Amazon, which obviously incorrect, but it gives you a flavor of how messy this data actually is. So, to test the significance of this data, we constructed 1,000 mock data sets with the same temporal and geographical distribution as the real data. We then calibrated those dates, and then we did 10,000 Monte Carlo picks on the fake data, and then ran a quantile regression on that data. Basically, what we did was run 10 million more regressions on fake data, and then, but with the same overall distribution as the empirical data, and then extracted a 95% confidence interval from it, which is represented by the blue boxes around. This is the intercept. This is a histogram of the intercepts of each of these 100,000 regressions. So the most common intercept date, that is starting date for the Guaraní expansion, is around AD 36. It's I think it's the clear dot that you may just about be able to see. And then the slope from which you can extract the speed is represented by this histogram. And the descriptive statistics are there. Long story short, based on this p-value, based on this confidence interval, we're given a p-value that basically shows that the data shows a non-significant relationship between distance from the origin and the dates associated with each archaeological site. In short, basically, we can't tell that the Guaraní expansion took place on the basis of radiocarbon data alone. Now, just to drive this point home, below is the same process carried out on the Pinhasi data published in 2005 on the spread of the European Neolithic, showing highly significant relationships, especially on the speed histogram, and slightly less so, but still significant just about on the intercept, the starting year of the process. So at this point we went back to the drawing board and thought, hang on, well, we know a dispersal must have taken place. What are we getting wrong? As I said, people have hypothesized that the Guaraní expanded via major rivers. So we figured, well, instead of using just as the crow flies distance from the point of origin, we will use a cost surface where travel is much easier relative to traveling over land, sort of approximating more likely dispersals through river valleys, major river valleys. That's what that looks like. It's slightly different regression, same data. That's the cost surface. It's actually, it's actually an outdated one. We've used more detailed data since then, but I didn't have a map for it to put in this presentation. Long story short, the cost distance model actually performed worse than the geosic distance model. It's even less significant, unfortunately. So at this point, basically what I'm presenting to you is negative results for the time of origin of the Guaraní expansion. We don't know what kind of speed they were moving at because we can't tell when it began. And second of all, finally, we tried to identify sort of plausible origins. Maybe we had the Fazenda Dona Carlota site as the wrong point of origin. After all, it's just the earliest date we have in the sample. Presumably, are other sites not in the sample which correspond better. This is very preliminary. I'm not going to go into too much detail with it. But basically, what we did is used an unconstrained search algorithm. We imposed a grid onto the study area, regular grid of points, simulated radiocarbon dates before the expansion for each of those points, and then calculated fitness values for each of those points, and allowed the algorithm to sort of run through each one and figure out which one best explains the distribution of dates that we have, the empirical distribution. We also did this for or rather, Fabio has previously done this for the European Neolithic and was able to end the domestication of rice in China, and was able to find within sort of 95% confidence where the likely region of origin is. Another team has done it for the geographic origin of Homo sapiens in South Africa, again with very high numbers. Unfortunately here, at most, the search algorithm can identify a point of origin sort of 35-40% of the with confidence only 35-40% of the time, and they all kind of are dragged further. What would it be? East from the actual later sites, not sort of west and north as one would expect for a phenomenon originating from Amazonia. And this may be because of the nature of the data, because these are also so the yellow star is the actual oldest site, and these green stars are other old sites sort of that fall within one standard deviation of the calibrated age range of the oldest site, and that may be kind of affecting this. But we're doing significance testing at the moment to check this out, to see whether we're wrong or the data is wrong. But I'm leaning towards the data. Oh, sorry, I should have said this is with the cost model. This is the geodesic model, but it says so on the legends. So originally, I presented this research in a session in CAA Oslo a couple of months ago, entitled "Can you model that?" And so we posed the rhetorical question: well, could we model it? And the answer is essentially no. And there are a variety of reasons for that. There are huge geographical and temporal gaps in this data. Basically, Paraguay isn't on the map. If that was a major dispersal vector, we need dates there. We also need dates in Mato Grosso do Sul and Mato Grosso, just to get started. Some more dates in the lower Paraná wouldn't hurt either. The size of the study area is problematic, and also the data quality, because some of these determinations are quite old and have quite large errors associated with them. Just to comment briefly on all of these things kind of together, there's a not often cited paper by Hazelwood and Steele, I think in Antiquity, on using Fisher-Skellum models to predict the speeds of dispersals. Again, they use European Neolithic data, but I swear this is the only equation in my presentation. But essentially what this means is that if you have a small distance as your divisor and a large standard error, you're going to get large errors in your wavefront velocity as well. Essentially, because the Neolithic has generally more dates and therefore smaller errors, you can be a bit more selective about the dates you use, and also is over a larger distance, the Fisher-Skellum models and models like ours works quite well. But because this is a relatively small, relative to the European Neolithic, relatively small area, and there are large standard errors associated with the data, it makes it very difficult to perform any kind of well, not difficult to perform analysis, but difficult to draw conclusions like you do for the European Neolithic. There's also the issue of whether or not pots are actually people. Obviously they're not, but the Guaraní expansion might actually be composed of several different processes. I found, digging a bit more into this, I found reference to sort of groups which mainly speak, well, who have a vocabulary which is mainly Guarani or Tupi-Guarani based, but overlying a substrate of Arawakan grammar, pointing to just that kind of anecdata points to sort of the Tupi-Guarani expansion being a more heterogeneous process than just the imperialists of the Amazon coming forth and spreading their culture ex Amazonia lux, if you like. So basically the take-home message that we could not match the absolute dates for the La Plata basin to a known dispersal process. the implications of that is that any attempted correlations between land use, bringing this back to the theme of this workshop, any attempted correlations between land use, environmental change, and correlation or causation with these things to do specifically with the Guarani is slightly spurious, I think, at this stage, without more and better data. So I'm sorry to present negative results to you, really, but that's all she wrote. Thank you.